Hi guys, welcome to KC4 review. We're looking at target 4C in this video. So number 11 says, between which two coordinates is the average rate of change -6? So remember, -6 here is important. When something's negative, it means it's going to be going down. That's kind of losing value depending on the situation here. So we're looking for something specifically that is going to go down 6, right? Because that's our rise, and then we'll look over our run, same as the slope. So if we're going down 6, that's because of that -6. And then we will go right 1, because -6, the same thing as -6 over 1. So that negative is how we get the down 6, and just 1 is a positive, is really positive, and so that's how we get right 1. Okay, so then what I'm going to do is I'm going to look at each point. So I'm going to go to the first point, I'm going to count how many down and over, second point, how many down and over, third point, up, or over, up and over, up and over. I'm going to see which one of those, between which two coordinates, I'm going down 6 and right 6. We'll just start from the left and work to the right. This first point here. To get to the next point, I go down, and I'm starting at 11, and it looks like I'm ending at 5, so that's down, no, -6. From 11 to 5, we have to subtract 6. So that's looking pretty good so far. And then to go over to that point, that's from a -3 to a -2, so I'm just adding 1 to that. So that's going to the right 1. And this is exactly what we want. So from that point there, down and over to the right is the average rate of change of -6. So we need to write down those coordinate points. So those points, this one here is -3, 11. You always do the x value and the y value. And then the other point here that we found is -2, 5. So then -2, 5. So and the point -3, 11 and -2, 5. For the rate of change is -6. Okay, number 12. Determine the average rate of change between -2 is less than or equal to x is less than or equal to 2. So what this is really saying is we want the x values between -2 and 2. So -2, I look over here, I see -2 for x right there, which is associated with the f of x, or the y value, 5. And then the 2, right here, I come over to my table and I see 2 for x here, and then that's associated with the -3 f of x. Okay, so I'm finding the average rate of change, which is just the slope. So I'm going to find the change in y's over the change in x's. The average rate of change is the slope. So those 2 points, I'm just going to write -2, 5, and 2, -3. Okay, so that was the yellow one. And here's the blue one that I highlighted for you. And remember, when we find rate of change with the slope, we call m is equal to, the top of is our change in y. So here are our y's. So we do 5 minus -3. 5 minus -3. And then our x's go on the bottom. Those are x values. So -2 minus 2. Okay, you always subtract. And I can put that right in my calculator, which I'll show you here. We go over. I'm going to start with a fraction. And I'm doing 5 minus -3. And on the bottom, -2 minus 2, and that is equal to -2. Okay, so I'm going to go back over here, and this is equal to -2. That's our average rate of change. All right, the function in this picture, number 13, the function models the path of an eagle descending for food. So this eagle is going to fly down, pick up its food, and then fly back up. Which interval represents the greatest acceleration? So acceleration, keep in mind, acceleration means to increase, to go faster, to go up, right? If you accelerate in a car, you're going faster. Not decelerate. Decelerate means to go down. So we want to look for parts where he is accelerating, going faster, okay? So I know it's going to have to be someplace over here on the right-hand side of the graph. Okay? And you can see that they put those numbers in there for us to help us. We want the greatest acceleration. So if I look in between each one, from this point to this point, I have acceleration of 1. Okay, and then from the next point up, right, that's acceleration of 3. And here, from the next point all the way up to the next one, acceleration of 5. So the greatest one is 5. So that time, that greatest acceleration, it happens right in those, between those 2 points there. And so what our graph between those 2 points is right here. I'll highlight it in blue. Oops. Go back to this page. Okay. Let me highlight that in blue for you. So that happens from a graph from here to here. So that's from these 2 points, okay, where the acceleration is 5. Greatest acceleration, I'm going to abbreviate that, happens between 2 and 3. So we can just say that between 2 and 3. Okay, number 14. Consider the function f of x is equal to x squared minus 2x minus 3. We are to first determine the average rate of change of the function from x equals -2 and x equals 0. If we're finding the average rate of change, we need to find the slope, the f. And the slope, we have to have change in y's over change in x's. And we only are given the x's, so we're going to have to find the y's. So what we do is we're going to take each of these x points and plug them in to our function. So it's going to look at like this. F of, our first one is going to be this -2. F of -2 is equal to, and wherever we see an x, we're going to plug in a -2 instead. Whenever I plug in a number, I always do parentheses. -2 squared minus 2, and then in parentheses again, we have -2 minus 3. Right, so -2 is plugged in each of these spots where we saw that x. And that's down here. And we can plug that right into our calculator to see what we get. So I'm going to go over to the calculator here. And we have parentheses, -2, close parentheses, squared, -2, parentheses, -2, close parentheses, -3, hit enter, and that gives us 5. Okay, so we plugged in exactly how we saw it. We go back over here, and I'm going to write equals 5. So that means the point is -2, 5. I got that from this -2, from all the yellow ones. And then that value we got after we plugged it in is right there. I'm going to do the same thing with the 0 value. Okay, so that's 0. So f of 0 is equal to, in parentheses, 0 squared minus 2, in parentheses, 0 minus 3, that equal to. Okay, I'm going to go back to my calculator and plug this in to see what value I get. So I'm doing parentheses 0, parentheses squared, minus 2, parentheses 0, close parentheses, minus 3, Hit enter, and we get -3. We go back over here. This is equal to -3. So our point then is 0, since that was the x, and we got -3. So again, here these zeros are all right here, and that's our x value that was given. We got that from up here. And when we plugged that 0 in, we got -3, so that's how we get that value there. Now, after this, we have to find the rate of change. So we're finding that slope. So our m is equal to, the x's go on top, so our x value is subtracted here. So -2 minus 0, I'm sorry, the x is going bottom. -2 minus 0, so -2 minus 0, x is going bottom. And then the y's, I'll use green for this one. The y's go on top, so 5 minus -3. 5 minus -3 is equal to. We can plug this right into our calculator exactly how we see it. I'm going to go back over to the calculator and put a fraction in first. And the top of the fraction is 5 minus -3. And the denominator is -2 minus 0. Enter, and we get -4. That's our slope, or our average rate of change. This is equal to -4. Boom, we're done. Okay, so then part B, sketch a graph of this f of x equals x squared minus 2x minus 3, and draw a line segment connecting the corresponding points x equals -2 and x equals 0. So I can do this and put this right into my calculator to help me graph this here. This I'm going to put on the calc. So again, back over to the calculator. I'm going to hit menu. Oh, I'm going to click the on button, and I'm going to go over to a new document. No, I don't want to save this, and I'm going to do add the graph. There we go. So our function is x squared minus 2x minus 3. Enter, and there's our function right there. Okay, so I'm going to go over and graph this the best that I can here. And if you click menu, you can trace the graph to see different points on it. I'm going to arrow this to the right. And one of the points we wanted was menu. Okay, sorry about that. So we're going to go to menu, analyze graph, and we have a minimum, the lowest point. We're going to find that minimum, so that's our bounds, and we have 1, -4. And then we're going to find our x-intercepts. And if you can't tell what those are, you can find them by going through the zeros, going over to the left and the right of each zero. That's -1, 0. And we can do the same to this one over here. Menu, analyze graph, 0. And so there's the other 0, we put it to the left. There's the 0, it says 0, put it to the right, and it tells us our other one. So these are the 3 points, -1, 0, 3, 0, and 1, -4. I'm going to go back and graph. And you will see that on the next video.